All right, so lights on or lights off? Clap, clap. Can you see your test like that? All right. So again, the average on this is pretty good. Your retest, for those of you who made below a 70, the retest is going to be, the way I say it is this: Tuesday at 8 a.m. Okay, my daughter makes fun of me for saying Tuesday, but that's how I was raised. And then I heard my dad the other day said, "Yeah, are you doing anything Tuesday afternoon?" And I was like, "That's where I get it from," and it makes sense. Yeah, thanks, Dad. But there's nothing wrong with Tuesday, right? But some of y'all say it Tuesday, right? Tuesday. Oops, I'm writing above there. That's why it's not working. Tuesday. And they're both correct, right? How would you say this word? Heuristic or heuristic? With a Y? Well, I guess Tuesday has those letters flipped, so that would be a bad example. But I was trying to say that has a Y sound in it, so should Tuesday. Hey, forget about it. The retest is on this day, okay, the second school day of next week. That'll be the 13th, I guess, 11, 13, 18, okay. So if you score below 70, of course, you can retest. Same test, all short answer, different numbers on the back, but same numbers on the front, all short answer. And there's no curve, so you got to get at least 70%, and if you do, you get a 70. Okay, that's the rule all year long. If you made above a 70 and you want to retest, that's fine. Come on in. You're welcome to do that. See if you can make 100. If you do, I've been known to be very kind and generous because that looks well when someone goes above and beyond and they succeed. And you shine favorably in my eyes. Okay. Comments or questions before we start? We're going to go over it. Let's get her done. Every morning. Find the range. Find the range of this function. Okay. This parent function is e to the x. The negative in front of the x is going to reflect it across the y-axis. So that's going to actually change it from something that would look like that. That's e to the x. When you reflect it across the y-axis, it's going to look like that. So now it's a decreasing function. The minus 15 moves the horizontal asymptote, which was on the x-axis, down to negative 15. The y-intercept is always above the horizontal asymptote, so it's at some new y value. We really don't need it. So the blue graph there is what it ends up looking like. All right, so from there we can get the range. Notice it is everything strictly above negative 15. Everything strictly above negative 15. So we need to find out which one that is. And it's letter E. We start at negative 15 with the parenthesis, and we cruise all the way to infinity, okay? If you chose B, then you are really, really close, right? In fact, you are so close to the horizontal asymptote, you're on it somehow, and that's not possible. So anyway, any question on number one? Notice I sketched it, right? A quick sketch can help you answer the question correctly. All right, number two, given the parent function e to the x again. Wow, okay, so as soon as you hear e to the x, you're thinking this fellow right there, e to the x. Which of the following equation represents a horizontal shift of that parent function 7 units to the right? All right, so give yourself a chance here. If you're moving 7 units to the right, in the exponent, you're going to have your horizontal shift. And if it's to the right, is it going to be x plus or minus 7? Minus. Good, because it's opposite. So if I can go through my answer choices and look to see where I have an x minus 7, I'll have it. Now, none of these are in standard transformation form. So on every single one of them, you're going to have to factor out the coefficient of x, right? So I did that. When you factor out the negative 2, it changes the sign, and you get x plus 7. And as I wrote up there, that's left 7, okay, not right 7. So it's not A. On B, you factor out a 2, a positive 2, and you get x plus 7 again. Again, that's left 7, so that's not going to be it. Letter C, you factor out a negative 2, and it changes both signs. You're left with x minus 7. And you're like, oh boy, that looks like that's the answer, right? But you know good test-taking strategies. If you get to the right answer at C and there's still 2 answer choices left, you should check them, right? Because you could have made a careless mistake. So let's just do that. On this one, if you factor out a negative 2, 2 is not a factor of 7, right? So when you factor out a 2 from a 7, you're left with 7 divided by 2, or 7 halves. That moves it right 7 halves. That's no good. And then similarly over here, when you factor out a negative 2, it changes both signs. You're left with x plus 7 halves. So that moves it left 7 halves. So yeah, now we checked all of them. There's only one right answer. It's answer C, as in C, senor. All right, any other questions on number 2? Number 3, look at that, another e to the blob. Wow, that's 3 in a row. If f of x equals 5 plus a third of e to the blob, then, compared to the parent function e to the x, which of the following is not a transformation? Now, not wasn't bold, it wasn't all caps, it was just a word there, right? So you want to read carefully. I put a box around it. So we're trying to find the one that is not true. So of the 5 answer choices, 4 will be true and 1 will not be true. What should we probably do first with this, if all of the answer choices describe transformations? Good. Put it into standard transformation form. The 5 at the front should go at the back, and then in the inside, we have to factor out the negative 1/3. So if you remember, if you have a 4/3 and you're factoring out a 1/3, remember factoring out is the same as dividing out. So what you started with, divided by what you're factoring out, and then you can stay, change, flip. The 3's divide out, and you're left with 4. And of course, it changes the sign because you factored out a negative. And you can always real quickly check by redistributing. You get negative 1/3 x, that looks good, and you're going to get minus 4/3, which is good. All right, so now we have it in standard transformation form. Let's go ahead and describe it from left to right. That's the beauty of standard transformation form. So that's what I have here. The 1/3 is going to be a vertical compression because it's exactly as it appears when it's with the y's. So it's a third tall, as tall as it used to be, which means you're compressing it by a factor of 3 vertically down. The negative in front of the 1/3, of course, is the y-axis reflection. And now the 1/3 in front of the x is the opposite. It's not a third as wide, but rather it's 3 times wider. That's a horizontal stretch by a factor of 3. And then we pick that graph up and we move it left 4, opposite of what it appears, and up 5, exactly as it appears. Okay? So those are the transformations. Let's see which ones are there. A, vertically stretched by a factor of 3. The answer choices aren't written in any particular order, by the way. Reflection across the y-axis, yeah. Vertically shifted up 5 units, Horizontally stretched by a factor of 3, yeah. Horizontally shifted left 4 units, So which one was it? Yeah, it was A. I said vertically stretched, and we had right there vertically compressed. So the answer is A. Yeah, very good, the very first one. So on that one, when you get to the first one, you're like, I don't think so. You do check out, hopefully, the other 4. Okay, dokie. Any questions on 1, 2, or 3? Any questions on 4? Just hold your question until we go over it. Okay. Number 4. If f is equal to 9 plus 9 times 0.009 to the negative x minus 9, this should have been question 9. Oops. What is the limit as x goes to negative infinity? All right, there's a couple of ways you could do this. Method number 1 is to do what we've been doing, put it into standard transformation form and sketch a graph. So the 9 in the front really goes to the back. We get 9 to the 0.009, and in the exponent, we need to factor out the negative 1. So that gives us then the quantity x plus 9. And so your parent function is 0.009, which is decay, right? 0.009 is decay. There's only one negative. It's in front of the x, and so that reflects it across the y-axis. So now it's a growth function. The plus 9 shifts everything up 9 units. So it lives above the horizontal asymptote, which is at 9. And so the blue graph down below is the final shape. Now you can answer the question, what is the limit as x goes to, and this just was careful reading. I know we print your test off on half pages, but you still should be able to see that negative, or if it looks like it's something that should be a negative, you're not sure, you could ask questions. But as you go to negative infinity, it's going off to the graph on the left, and you're getting closer and closer to the horizontal asymptote at 9. And so the answer was C, right? The limit as x goes to positive infinity is infinity. So if you didn't see that negative there, I apologize. Is there a way to do it without the graph? Yeah. Okay. This is a real informal method. Mathematicians would shriek if you did this, but you could actually plug negative infinity in for x. You get 9 plus 9 times 0.009 to the, now be careful, when you plug in a negative infinity for x, you get negative times negative infinity, which makes that what? Positive infinity minus 9. And now we just simplify it. What is infinity minus 9? Infinity, right? What is 0.09 to the infinite power? No, 0.09 to infinity is 0, right? Think about this. 0.009 is 9 1,000ths, right? And if you raise that to the infinite power, that would be 9 to the infinity over 1,000 to the infinity. Which one's growing faster? The bottom. And so it's going to what? 0. So if that's going to 0, what's 0 times 9? 0. And then what's 0 plus 9? 9. So you can get the answer that way. Okay. All right. Any questions on number 4? Some people I know missed it just because they didn't see the negative in front of the limit sign. Or underneath the limit, I should say. All right. Number E. 5, sorry. Which of the following again is not true? Which one is false? So 4 of them are true, and 1 of them is not true. Parent function is 2. This one is in standard transformation form. So again, I just did a quick little sketch. We're moving it down 15 units. In this case, if you find the Y-intercept, because that's one of the choices, I did that right here. Plug in a 0. You get 5 times 2 to the 0 plus 1, which is to the first, minus 15. So by your Dear Aunt Sally's rules, you have to go 2 to the first, which is 2. 2 times 5 is 10. 10 minus 15 is negative 5. So I kind of reflected that on my graph, or showed that on my graph. And so there's my graph. And so, first of all, since I already found the Y-intercept and I know it's 0, negative 5, I know B is correct. Part A says, is there a horizontal asymptote at Y equals negative 15? And I'm like, heck yeah, there is. Okay? Now, if you don't read carefully and you get to part A, you're like, horizontal asymptote at Y equals negative 15. Yeah, there is. That's the right answer. But that would be if we were looking for the one that was true. Okay? So 4 of them are going to be true. We're looking for the false one. This says the domain is all real numbers. That's kind of the computer way to write all real numbers. And that's true. This one says the range is negative 15 to infinity. That's also true, everything above that. And then it's a decreasing function. I put, no, it's actually monotonic or strictly increasing, right? And so E would be the one that is false. That's answer choice E. E on number 5. 5 is E. Questions so far? So good so far, so good? Yeah. Okay, sweet. Number 6, the graph of the function g of x equals 32 to the x power can be obtained from the graph of 2 to the x by what? Okay, so the way to do this one is to begin with the end in mind. Start with 32 to the x and see if you can't write it in terms of base 2. Well, we chose one that was kind of easy. If you replace 32 with 2 to the 5th, because that's what 32 is, then you can raise the power to a power by multiplying, and you end up with g of x equals 2 raised to the 5x power. And so now it's obvious, right? You would take the graph of 2 to the x, and what would multiplying by 5 do in the x? It would be a horizontal compression by a factor of 5. And so all you got to do now is look for that one, horizontal compression by a factor of 5, and it's answer choice A. Okay, start with the one you want to end up with and write it in terms of the first one. Questions on that one? It's the only one that makes it stupid? What did you say? Oh, steeper. Oh, okay, yeah. Actually, if you shift it left also, it'll make it steeper. Yeah, shifting it left would make it steeper too. But yeah, you could probably reason, Eli, to get the answer as well. Yeah. Now remember, when it says none of these, that's not like the answer you put when you don't know how to answer it and say, I thought that was right. I didn't know how to do it. That's not what that's for, right? Okay, good. Number 7. Which of the following is equivalent to this? Oh man, this looks kind of familiar, kind of like on a practice test. Yeah. All right. So it's actually a little bit easier than one of other tests, I think. Cube root of a squared, that's the same as a to the 2/3 times a to the 5x plus 2th power. And then all you got to do is add the exponents, so you're not afraid of fractions. 2/3 plus 2. 2 is how many thirds? 2 is 6/3. So you get 6/3 plus 2/3, that's 8/3. And you get a to the 5x plus 8/3, which is answer choice C. We didn't even factor the 5 back out. What would it be, though, if I did factor the 5 back out? It would be a to the 5 times x plus, what would be the new number? That is a great question. I could have done this. Factoring out of 5 is the same as dividing out of 5. What's 8/3 divided by 5? Or what's 8/3 times 1/5? 8/3 divided by 5, which is 5 over 1. Stay. Good boy. Change. Flip. 8/15. Man, in hindsight, I should have put that as the answer. That might have prevented a few other people from getting it. Or not. Maybe it just would have, bless you, maybe it just would have given you a little bit more joy because you got to have a little bit more fun by doing one more thing. I'm sorry, guys. Okay. At least we can enjoy Carl Sagan Day together. Carl Sagan? You know who Carl Sagan is? Yeah, he's like the famous astronomer. Yeah. Who's the famous astronomer now? Neil Tyson DeGeneres? What's his name? DeGrassi? What's his name? Tyson DeGrassi? Neil Tyson DeGrassi? Is that his name? Neil deGrasse Tyson. There you go. He's like the famous astronomer now. He did the same show later that Carl Sagan started. So Carl Sagan was the Neil deGrasse Tyson DeGrassi originally. Yeah. Carl Sagan was also an author, a brilliant scientist, an astronomer. Not an astrologist. He didn't like read your palm and say, ooh, you're an Aquarius. He wasn't that. He's like, look at the stars. Here comes a comet. Okay. Anyway, Carl Sagan. Carl Sagan. Bob Saget. Question 8. A group of 15 bacteria. Oh, that's bad news. Can you see them all huddled together in an alley with leather jackets all smoking or vaping, I guess? Yeah. Oh, look at that group of bacteria. They're doubling every 3 hours. So remember, if it doubles, we have a growth factor of 2. At that rate, about how many hours, because I rounded, about how many hours will it take for the population to reach 95,000? We did a lot of these, right? So I wrote the model first. I called the amount at any time A. The initial amount was 15. The growth factor was 2, so that was the base. And then it doubled every 3 hours, okay? And notice because it says how many hours, and I tell you it doubles every 3 hours, we can use hours as units. So it's t divided by the time it takes to double, which is 3 hours. So t divided by 3, and I wrote t in hours. So there's your model. So all you got to do is now set it equal to 95,000. And then how do we solve that? You could solve it algebraically. I don't know if anyone did that. Could you guess? You could try out your answer choices, right? That's called back solving. You could plug 57 in for T, 63 in for T, and see which one approximately equals 95 grand. That's not a bad test-taking strategy, right? But we have another strategy called math. Right? Yeah, math. 35. Yeah, thank you. All right, so let's go ahead and do it the math way. Get rid of all this E junk, this calculus clutter. All right, so 15 times 2 raised to the power of Grayskull. That's a He-Man joke. No, okay. Yeah. Eli, you got that one too? Yeah, he knows He-Man and Ellen DeGeneres DeGrassi Tyson, whatever his name is. 95,000. All right, and then the average person goes Zoom 6, and they're like, I don't see anything. Right? Let's go to the window. We'll do X min. How about -1? Now your X max, that's the one you kind of have to guess on. But if you look at your answer choices, those are X values. So you can use those as a hint. What's the largest X value we have there? 68. So let's go to Zach, 69. No, let's go to 72. Let's go to 72. -1. Now, we want to know where it intersects 95 grand, right? So let's go up a little bit above that to 100 grand or something like that, okay? And now I hit graph. Oh yeah, there it is. So now we hit second trace, number 5. There's only 2 graphs. There's only 1 point of intersection, so enter. Come on in already. 37.886, all right? 37.886. And, of course, that squiggles 38, right? And so the answer is D, as in, dang, that was fun, right? Yeah. Okay. And then number 9, what's the percent decay rate? All right, we know this is decay because the base is 0.745, which is between 0 and 1. The average person that doesn't really know what they're doing is going to convert that to a percentage and get 74.5, and then they're going to say, hey, 74.5, and they're going to get it wrong, right? So we take either 74.5 and subtract from 100, or if we're crazy with a capital K, we can subtract 0.745 from 1. It's kind of the same thing. That's what I did. And you get 0.255, and then you can convert that to a percentage and get 25.5%. Okay, either way. So remember, if we lose 25.5% every cycle, we are retaining 74.5%. And that's what the base does. It tells you what the current amount is. Not how much you lost, but what is the current amount. Okay, that concludes the multiple choice section of the examination. Are there any questions, inquiries? Oh, sure. Yeah. You certainly may go to the bathroom. Yeah. Any other questions? No? All right. So we practiced the heck out of the free response. If you notice, the free response question had no more heck in it when you saw it, right? It's like, man, the heck's all gone. We practiced the heck out of it. Okay? So I was trying to come up with an interesting topic. Okay? So I was like, hey, what if Elvis played ACL with Metallica? And I kid you not, I had this idea first, and then I wrote the question. And then I was like, it would be great if I could accompany the problem with an image. So after I had written the question, and in my own head thought of Elvis performing with Metallica, I just said, let's try it. And I Googled Elvis with Metallica. And only one image of Elvis with Metallica showed up. It was the very first one, and it was this one. And I was so elated that someone else in the universe had the same idea that I had and had taken the time to Photoshop Metallica into an old Elvis performance. Or the other way around. Yeah. So, some people pointed out to me on the test that Elvis is dead. And I didn't really know that until they told me. So, I guess it can't really happen, right? But yeah, Elvis supposedly lives with Tupac in a cave in Afghanistan somewhere. Oh, Serbia? Okay. So Elvis came out. So anyway, there's Trujillo on the left, there's Hetfield, there's Lars Ulrich on the drums, and Kurt Hammett on the right, and then you got the king, Elvis Presley. And I was curious what song they'd be singing right here, so I asked y'all, and some of y'all came with some really good stuff. But anyway, let's read. How much time do we have? 13 minutes? Okay. At the most recent ACL concert in Austin, on a particular day, a rumor began to spread among the festival goers that Elvis Presley was going to make a special appearance with Metallica. The number of people who have heard the rumor at T minutes is given by the following function. Okay, so there it is. It's a logistic. I put calculator window here because I had already figured it out. So let's do that. I'll get flush. It'll flush. Okay. And then how do we get the horizontal division bar? Nope. Alpha Y equals. Yeah. All right. So 42 grand. And over 1 plus 89. I think everybody but one person had it typed in correctly. Second ln negative 0.1x. Somebody maybe put like 0.01 because they had numbers that were very, very close but not exact. Okay. So now let's just do this together. -1, we're measuring time in minutes on the x-axis. So let's let, 3 hours go by. How many minutes is 3 hours? 180. Oops, I did that in X-min. That's not what I wanted. -1 to 180. And then we're measuring festival goers, people that have heard the rumor. So -1. We know 42,000 people. So let's go to 50 grand. And I did actually look up, and at the most recent ACL on the record for that one day attendance was 42,000. So that's a lot of people. Yeah, sure. So that number is real. Okay, now I hit graph, and I'm like, okay, I see the S-curve, and I'm happy with it. I don't need to really trim off anything. I'm just looking to see an S-curve. So I know I have it in there correctly. So here we go. Question 1. What was the initial number of people who had heard the Elvis Metallica rumor? Round to the nearest person. Of course, you could truncate. So all you have to do is go back to your calculator. You could do it from the home screen, but I'll do it from the graph screen. I'll do it from the home screen, though. Alpha trace, number 1. Open parentheses, 0, close parentheses. And you get 466.666, okay? So most people just went W of 0 equals 466 people, or W of 0 equals 467 people, which is good, all right? If you are going to write out the 3 decimals, W0 equals 4.666, and then you're going to round, you cannot use an equal sign again. So notice I did that, but I didn't use an equal sign. I said, so 466 or 467. You could also say squiggles 466 or 467. But you cannot do this. You cannot say equals that and then underneath there say equals 467. Why not? Because they're not equal. And that is a subtle thing that maybe you think is innocent, but it's not right. So don't do that. Okay? So anyway, that was worth one check. The units total were one check. So if you had W of 0 equals 466 or 467, it had to be in the presence of W of 0. You got the first check. Okay? B, after how many minutes will 10,000 people hear the rumor? Well, W of T equals 10,000 was a check. Most people wrote that. Okay? Then you need to find the answer. So in Y2, you sketch 10 grand. And you hit graph. Second trace, number 5. Enter, enter, enter. And you get 33.254. Okay? So 33.254. So notice what I did. I said, so 33 minutes. Okay? If you write down the 3 decimals, you could then put is approximately 33 minutes. Okay? Or you don't even have to write the 33.254. You could just say T equals 33 minutes. All right? So that was another check for having T equals 33 minutes. And the units, if you have them, you're eligible for the 9th check. All right? Here's what you don't want to do. Some people did this. They did W of 33 equals 10,000. That says kind of the same thing, but it doesn't communicate how you did it. And I still wouldn't know how you did it. Did you just randomly plug in values and evaluate it until you got close to 10,000? Or did you actually find the point of intersection? I can't tell if you set it equal to 10,000 and found the point of intersection, or plugged in a 33 to got 10,000. So that's not the way to do it, okay? You set W of T equal to 10,000. Now I know you're solving that equation. And then underneath there, T equals. Okay, after how many minutes was the rumor spreading the fastest? Well, most people figured this out, right? If there were 42,000 people there, it's going to grow the fastest when half of them, or 21,000, have heard the rumor. So you got a 4th check by setting W of T equal to 21 grand. And we do kind of the same thing now. We graph 21 grand and find the point of intersection. So in Y2, just type that in, 21000. How much time do we have? 5 minutes? 6 minutes? Okay. Second trace, number 5. Okay. Enter, enter, enter. And we get 44.886. So you could have put T equals 44 minutes or T equals 45 minutes. That was the 5th check. All right. How many people have heard the rumor after 2 hours? I got some people on this.
Yeah, you did.
I got some people on this. We're measuring time up here in what? Units. We're measuring time in minutos. And so I say after 2 hours, 2 hours is 120 minutes. So you can't find W of 2, you have to find W of 120. And so it had to be in the presence of W 120. Some people put W of 2, and then they had 41,977, which is interesting. That would still be wrong because this wasn't 120. So maybe you figured out what you did wrong, but you didn't change it on the other end. Oh, yeah, and you should have changed this. That's all. Okay, according to the model, how many people attended? I was just looking for the numerator, 42,000 people. Some people put the limit as T goes to infinity of W of T equals that. That's great. Here's what you don't want to do. You don't want to say W of T equals that, because W of T does not equal that. W of T is a variable function, and it varies, okay? So if you did that, I didn't take off. I just went like this. I didn't see that, okay? Don't do that. Don't do that. Okay? Again, if you're going to put anything, you're going to put the limit as T goes to infinity of W of T equals that. All right, and then if Elvis were to actually appear, if 99% of the festival attendees had heard about it, 0.99 times 42,000 is 4158, or 41,580. You need to set it equal to 41,580, find the point of intersection, and it comes out to be 90 or 91. Now, for the 8th check, there was a higher standard. You had to have all of this stuff for the 8th check. You had to have the W of T equals that and the T equals for that one check. I didn't give you 2 checks for that like I did on the others. So that was worth the 8th check. And then the units. If you had the correct units all the way through, you got the 9th check for the units. Okay? Now, a lot of great people put great songs. My ideal song would be Heartbreak Hotel mashed up with Nothing Else Matters. That would be my personal favorite. I'd love to hear that. Some people said the Star Spangled Banner, which is not bad. Enter Sandman was pretty popular. It's funny, a lot of people knew some Metallica songs. One of my favorite Elvis Presley songs, aside from Suspicious Minds, is Return to Sender. And you put Return to Sender. So I saw that and I was like, wow, most people don't know their Elvis catalog, but that person you do. Yeah. Forrest Gump did what? Oh, he taught Elvis how to dance and wiggle. Yeah, that's right. That's right. So anyway, that wasn't worth any points. I was just kind of curious to see what y'all would do. And some people put, I don't know what song they would sing. And I was like, that's okay. It's just an imaginary situation. And then some people put, Elvis would not sing anything because he's dead. And I'm like, thanks for playing. So anyway, there it is. When's the retest? Tuesday. Have a fantastic day.